All right, we are continuing with systems of inequalities, all right? And so we did this yesterday, all right? And what I told all my students to do was to go to Desmos and type both of them in. Now, what do you guys notice about these two equations that I typed into Desmos? What would you say? They are exactly the same. Now, this is in standard form, and this is in slope-intercept form. Now, something you guys need to understand. This is kind of weird. Do you guys see how that says less than? But that says greater than? It's kind of weird, huh? But check this out. What was the last thing we had to divide both sides by when we changed it from standard form to slope-intercept? We had to divide by what? A -3. So what happens to the inequality sign? It flips. So what happened to this inequality sign when we divided by this -3? It flipped and it made it what? Greater than. Now understand, greater than shades everything above. So I'm gonna go ahead and delete this one real quick because this is one we have, and I'll go ahead and change it to red since we have red in our drawing. All right. Can everybody see that if it's greater than, everything is shaded above? But if I change that right over here, if I change that to less than, it's shaded where? It's shaded below. Has the line changed? No. What's the only thing that changed? Where it was shaded. Now, does everybody see here in Desmos it has a dotted line? Dotted line means not equal to. So I'm going to put an ordered pair here. So just kind of follow along if you would. If I put the ordered pair 0, 4. Oh, not 0, 0, comma 4. This is considered to be a part of the solution because it's anywhere in this what's called the solution region. So, right? What if I put 5, comma 0? Is that still in the solution region? Yes. Now what about 7, 0? Is that in the solution region? No. What if I put 6, 0? No. Now let me explain why. Does everybody see that 6, 0 is right here? Why is that not considered to be a solution? How about this? It's on the line, right? But the line is what? Dotted. So if it's dotted and it's on the line, it's not a solution. But if I change this from a greater than to a greater than or equal to, do you know what? Now that's considered to be part of the solution. It's part of the line. And right now, you're allowed to be a part of the line when you have what sign? The equal to sign right there. But if you don't have the equal to sign, then that's not considered to be a part of a solution. So that is a huge statement you need to put in your journals. Oh, hold on. Let me pause it real quick because I need to make sure students write this down because some students. All right, so what we're going to do now is we're going to go back to this area right here. And what I'm going to do is we're going to make a new inequality. So this is the new inequality I want you to do with me if you were here yesterday. I'm going to go change it to blue. All right. And I want you guys to write y is greater than or equal to 5 over 2x minus 5. Okay? Y is greater than or equal to 5 over 2x minus 5. Now, understand the slope of this inequality, the slope is going to be 5 over 2, and the y-intercept is going to be -5. So now we're working in our journal. Okay? Now we're working in our journal. So please put that in your journal. Now, what I'm going to do, for those of you who are interested in how to change it from, by the way, what form is this? This is in slope-intercept form. If you're interested in knowing how to change it to, quote, standard form, this is what you would have to do. But you don't have to do this unless you really want to, okay? So, here we go. Here's how you change it to standard form if you wanted to see what it looked like in standard form, all right? First thing I'm going to do is I'm going to take this 5 over 2x, I'm going to move it across and make it a -5 over 2x plus y is greater than or equal to -5. Now in standard form, you can never have a negative out front, and you can't have a fraction. So what I'm going to do is I'm going to multiply everything by a -2. So I'm going to distribute a -2 into everything. So this is only for the learners who actually want to know how to change it from slope-intercept form to standard form. A negative times a negative is a positive. You're left with 5x. -2 times y is -2y. But if I multiply an inequality by a negative, the sign has to flip. So I would have to flip this inequality sign, and a negative times a negative is a positive, so that would be a 10. So everybody, what I'm going to do is I'll prove it to you once we go over to Desmos that this is our inequality in what's called standard form versus slope-intercept form. Okay? So it looks like this way in slope-intercept. It looks like this way in standard form. But now we're going to go ahead and plot it. Okay. All right, so sliding back over. If you missed that, you can just pause and rewind. What's our y-intercept? Our y-intercept's at a -5, which is right there. So we're at 0, -5. And if we're going to apply a 5/2 slope, we literally have to go up 1, 2, 3, 4, 5, and over 2. So it looks like our x-intercept is going to be at a 2, 0. I'm going to go up 1, 2, 3, 4, 5, and over 2 more right there. And now I'm going to carefully craft my line that should just go past through all of those points. Now I'm going to save all the shading for the very, very, very end. I'm not going to shade as I go along. I always shade at the very end. Okay? All right. Now, in Desmos, I want us to type this in. Y is greater than or equal to 5/2x minus 5. So I'm going to go over here to Desmos. Okay, I'm going to take care of that right there. I'm going to put y is greater than or equal to 5/2x minus 5. All right, except I'm going to change it to blue. Okay, so we'll take a look at it. You can kind of see the two. You can still, even if you're graphing on your own, you can kind of see, hey, there's my y-intercept. Can everybody see what the solution region would be? Right now, where's my solution region? Where do the colors overlap? They overlap right here. And it's kind of cool because guess what? When you mix red and blue, what does it create? It creates purple. All right? So kind of they basically use what's going to happen in real life when you mix things, okay? So this right here, this is a solution region. All right? So I'm going to have a quick question real quick. Is 2, 0 a part of the solution? What would you guys say? Yeah, it is. Why is it a part of the solution? Because is this a solid line right there? It is. Okay? Well, you can obviously what? Is 1, 0, is that a solution? Is that in the purple region? Yeah, so that's a solution. Okay? But if I said 1.50, yes. But if I say, what about 2.50? Is that no longer in the solution? Okay? What about this point? 0, -4. Is that a solution? It is not. You know why it's not a solution? It's on the dotted line. Okay? What about 0, -3? Is that a solution? Yes. So that would be considered in the solution region. Very good. All right. Let's keep on moving. Let's go back to our last drawing. Here's our last drawing. We're going to do it in, let's do orange. I like orange. It's very October-y. All right. Yo, I love dreamsicles, man. Yeah, one of my students said dreamsicle. Now I got to go get some. All right, so we go. Put y is less than or equal. And I think I want my y-intercept to be there. And I want my x-intercept to be there. So I'm going to have a slope of -3/2. So I'm going to put y is less than or equal to -3/2 x. And then I'm going to put +3. Okay? Now, this is what I'm gonna graph. So I'm gonna graph this guy. I'm gonna put m equals, my slope is -3/2. My y-intercept is at a 3. And yes, once again, what am I gonna do? I'm gonna show you how to change it into what's called standard form. So this isn't slope-intercept form. I'm gonna change it to standard form. So I'm gonna take everything right here. First thing I'm gonna do is I'm gonna take this -3/2x. I'm gonna throw it across the inequality sign, which makes it a +3/2x. Wait a second, are you saying that anytime you move something across an equal sign or an inequality sign, it just becomes the opposite of what it is? Yes, that's it. It's easy. It doesn't take that long. Less than or equal to a 3. Now, are we allowed to have fractions in standard form? The correct answer is no, not allowed to have fractions. So how do I get rid of a denominator of a 2? I just multiply everything by 2. All right, so I distribute and distribute and distribute. All right, these 2's cancel out. You're left with 3. 3 times 2y is 2y. 3 times 2 is 6. Boom, you're done. So what does this represent? This represents standard form for this guy. And some of you might be in the video going, you said you were going to show me that this was equal to this. You're right, I did. I apologize. I'll do it right now real quick, okay? 5x minus 2y is less than or equal to, what did I say? Less than or equal to 10. All right, there we go. Does everybody see that these are the same? Nothing changes, does it? Same. All right, here we go. So what's our final one right here? I want you to type in to Desmos, y is less than or equal to negative 3 over 2x plus 3. Go ahead and type it into Desmos, and I'm going to go ahead and finish graphing this. Down 3 over 2, down 3 over 2. Let's draw a beautiful, nice orange line. Am I going to make this solid or dotted? What do you guys think? Solid or dotted? Solid, very good, because that's what it says equal to. So if it's equal to, it means solid. There we go. There's my, oh, I was a little bit off. Just like my personality. Just a little bit off. Okay. There we go. So there it is. Now, let's check it out. Let's go to Desmos. We're going to type it in. Y is less than or equal to negative 3 divided by 2. X, oh, and what? Plus 3. Except I'm going to change the color. I'm going to change it to orange. There we go. Wow, everything is super orangey. All right, it's like we're in Dreamsicle land. All right, now, check this out right now. I'm going to actually change it from orange to a better color. Let's go ahead and go purple. Yeah, that's probably better. Can you guys see right now where the solution region would be? Where's the darkest? Where's the darkest of all of the, you know what, how about that? I'll letter them, okay? So I'll letter them. You guys tell me what you guys think the darkest is, all right? So let's start with here. We'll call this one A, region B, region C, region D, region E, or region F. Of all those, which one seems to be the most shaded or the darkest? Which one? F. Very good. So everybody, we call this, guys, we call this the solution region, okay? We call that the solution region, where when you're shading everything, it becomes the darkest. So if you were using a pencil and you were just starting to shade each region, depending on what you were doing, wherever it's the darkest is the solution region. Okay? So we're going to show you how to shade. All right? Here, how do you shade? So we're going to start. You guys ready? Get your pencils out. All right? I would not suggest, you can use colored pencils, is fine. I would not suggest using pen because it's very difficult. You would have to do cross hatching and that takes a long time. So we're going to use pencils. So right now, first thing, it says what? Y is what? Greater than 2/3 x minus 4. So I have highlighter. So that means greater than means I'm shading above. So I'm going to make it nice and thick as possibly. And hopefully, oh, I went across the line. I'm not supposed to go across the line. So I apologize if I go across the line. Hopefully my kindergarten teacher will not see me drawing outside the lines. Whew, that was a close one. Mrs. Nicoli would not have been very proud of me if I was going to draw over that line. So right now, what does this red area right here represent? That represents the solution region of what? Of my red inequality right here. That's the solution region. All right, next one I'm going to do. The blue one, it says y is greater than or equal to 5 over 2. So we're going to do greater than or equal to. What does that mean? Here's my blue line, right? I got to go above it. This is above it. This is below it. So I got to shade technically everything where? Above the blue line. I'm doing my best not to cross over it. Please don't mess up, board. Please don't mess up. There we go. All right, so everything above it is shaded. Okay? All right, there we go. Next one, orange. Y is less than or equal to. Now, less than or equal to means below it. So if I'm going to go below the line, do you guys see the orange line right here? I got to shade everything what? Below it. I didn't do a very good job. Not too bad. Huh. That's not a very good. See how orange is not a really good shading? But hopefully, can you still see how it still gets the darkest area? So here's what I want you guys to label. Can you guys label this right here? I'm going to label it in green. Hopefully you see it better. This right here, everybody, is what's called the solution region. Yeah, where all of them overlap, that's called the solution region. So literally any point in here, any point here is considered to be a solution. Any point on this line right here is a solution. Any point on this line right here is a solution. But any point on this line, that's 0, -4, that's not a solution because it's on the dotted line. So where does it have to be? It has to be either on the solid line or in the region for it to be a solution. Does that make sense? Hopefully it does. Hey, last 10 minutes of class, we get to play. So right now, go to quizzes, and we're going to play a game. All right, let's take a look at this, everybody. All right, here's your very first question. All right, so can you guys see where the solution region is? Right here. That's the solution region. Now here's a line. This line has a slope. The slope looks like it goes up one and over 1. So that's a slope of 1. It has a y-intercept at 4 right there. It's above it, and it's equal to this line. So this is going to be y is greater than or equal to 1x plus 4. That's this line right here. The next line is this one right, that dotted line, and it's still shaded above. So that's still going to be y is greater than, but what's the slope? The slope goes down 1 over 1, down 1 over 1, down 1 over 1. Slope is -1, so I know it's going to be -x. And what's the y-intercept right there? The y-intercept is at a -1. So here are your two answers. Y is greater than or equal to x plus 4, and y is greater than -x minus 1. Those are the two answers that you are looking for. So when you're trying to find the answers, y is greater than or equal to x plus 4, and y is less than -x minus 1. Okay? So I'm going to go ahead and pause it while you guys do that. All right, so which is not a solution? What's one of the ordered pairs that they give? Tell me one of the ordered pairs, quick. What is it? 0, 3? What's another one? 0, -1? What's another one? 4, 0. And the last one? 6, -2. All right, so 0, 3. Is that a solution? Yes. 0, -1. Is that a solution? No. Why? Because it's on the dotted line. 4, 0. Is that a solution? Yes. 6, -2. Is that a solution? Yes. So these are all solutions. This is the one that's considered to be not a solution. Why? Because this line is what? Dotted. That's why 0, -1 is not a solution. And you had to find the one that was not a solution, not the one that was. This one, it says sketch the graph, whatever this is. Now it says x is what? Greater than or equal to. Well, this one's really, really, really easy, because if it says equal to, what kind of line do you have to have? Solid. Is that solid? No, that's not solid. So there's only one literally answer, even if you didn't know that x is greater than or equal to is a vertical line. All right. Now, by the way, do you know what this one would be? This one would be y is less than -2. This would be x is less than 2. And this one right here would be x is less than -2. Okay? So if it's solid, it has to be what? It has to have that equal to. If it's dotted, it's going to just have the inequality sign. Okay? Horizontal is always y equals, vertical is always x equals. All right? All right, take a look at this. Wow, it's kind of shady here. All right, but where is this? This is right here where x is what? X is at a -3. Is it shading to the right or shading to the left? To the right. So it's going to be x is greater than -3. Why is it just greater? Because that's not a solid line. That's why it's greater than. Okay? All right. Tell whether this ordered pair is a solution. What does that say? -3, 0. What does this mean? That's my x, that's my y. So if my x is negative 3 and my y is 0, is negative 3 plus 4 greater than 0? Is negative 3 plus 4, that's a 1. Is 0 less than or equal to 1? Yes. Let's check the next one. Put a 0 for y. And what are we plugging in for x? We're plugging in a negative 3. Is 0 greater than or equal to negative 6 minus 6? Is 0 greater than or equal to negative 12? Yes. So is this ordered pair a solution of the given system? I'm going to say yes, it is, because it meets both conditions. And these are the types of questions that you're going to need to know how to do. Now, the last thing I'm going to do right now is I am going to go to Desmos. I'm going to type this one in real quick so you guys can see. All right, let me look at it real quick. It said what? Less than or equal to x plus 4. Here we go. Y is less than or equal to x plus 4. And what was the other inequality? Y was greater than or equal to 2x minus 6. This is the last one we're doing, guys. Y is greater than or equal to 2x minus 6. And what was the ordered pair that we had to test? Was it negative 3, 0? What was it? Negative 3, 0? Okay, look. Negative 3, comma 0. Can everybody see the solution region? You guys see it? Now, what was different about this one than the previous one? This one, it didn't give you a graph, did it? You had to kind of plug it in, but that's what you're doing. Hope this was helpful. Have a good day.